Hello, today I'll be presenting about bagasse, a renewable raw material. So, this is the table of contents for this video. What is bagasse? It is a fibrous residue remaining after sugarcane juice extraction and one of the most abundant agricultural byproducts worldwide. It is mainly composed of cellulose, hemicellulose, lignin and ash. It is an environmentally friendly alternative to synthetic materials, suitable for multiple industrial applications. Today, we'll be focusing on the soda pulping process of bagasse because it is widely used for processing of bagasse material. Firstly, bagasse is collected from sugar mills after juice extractions are cut into manageable pieces. It is de-pith and washed to remove residual sugars and impurities. The impregnation process includes soaking sodium hydroxide solution with bagasse to allow the chemicals to penetrate the raw materials, softening it and accelerating the subsequent cooking process. So, this is the hammer mill de-pither, a specialized machine designed to separate pith by using high-speed rotary hammers. Next, the delignification process includes heating the impregnated material by breaking down lignin and separating the cellulose fibers. And then the pulp is washed thoroughly to remove dissolved lignin and residual chemicals. Then, the washed pulp is screened and separate usable fibers from rejects and unprocessed particles. And lastly, the spent cooking liquor, which is black liquor, is collected and processed to recover chemicals and energy for reuse. Bleaching is actually an optional step, so the pulp is treated ideally with chlorine-free agents with H2O2 to reach desired brightness. The main byproduct of soda pulping process is actually black liquor, but then we have the other byproducts, which is pith and silica. So, black liquor, pith and silica each have their own new product pathways. The origin of black liquor is from washing and screening station. It is transported via closed-loop conveyor or pipelines to a chemical recovery unit, handled as fluid, and time is a critical factor to prevent scaling in pipes. For black liquor, we have three main pathways, which is bioenergy, biofertilizer, and biofuels. So, this is the schematic diagram for black liquor pathways. As for pith, we can make it into animal feed additive, and for silica, it can be turned into industrial fillers like rubber and paint. So, what are the risks of neglecting these byproducts? One of the effects toward pulp production mill is reduced pulp quality. And then we have high operational costs, which is sodium hydroxide that can be reused is not used wisely. Next, we have silicate scaling. The high silica in bagasse forms glass-like scales in pipes and boilers, causing frequent equipment failure. As for the effect towards environment, we have water toxicity. Direct discharge of black liquor causes massive oxygen depletion, high COD or BOD, thus creating dead zones for aquatic life. Next, it can cause soil damage, which is a milling locus. The high alkalinity, pH 10 to 13, of untreated waste can alter soil chemistry and preventing future agricultural use of the land around the mill. Lastly, it affects workers' health. The high alkalinity also causes severe chemical burn and respiratory risks to mill operators. In conclusion, bagasse is a sustainable and low-cost biomass that can be produced through soda pulping to produce paper and valuable byproducts. Reusing these byproducts improves efficiency and reduces environmental impact, making the process more sustainable overall. These are the references I used for this video. That is all from me. Thank you.